Water. It falls, flows, evaporates, and does it all over again. But this isn't just nature. It's a finely tuned mathematical machine. The water cycle, or hydrologic cycle, is powered by energy and governed by physics, chemistry, and probability. It starts with the sun. Solar energy heats Earth's surface, causing evaporation. The rate of evaporation depends on temperature, humidity, and wind, all calculated with differential equations. Next, condensation. As water vapor rises and cools, it reaches the dew point, the temperature where it condenses into droplets. Here, thermodynamics steps in. Energy is released as latent heat, fueling storms. When enough droplets form around tiny particles, dust or sea salt, they cluster into clouds. Over time, gravity wins. The droplets combine, grow, and fall. Precipitation happens when droplets reach a critical mass. That's where fluid dynamics and probability theory collide. Will it rain? Depends on millions of variables, all plugged into weather prediction models. Rain, snow, hail, they're just variations in temperature, air pressure, and droplet behavior, all modeled in real time with math. Runoff flows into rivers and oceans. Some seeps underground, into aquifers modeled using porosity and permeability equations. It's a closed-loop system, with complex variables and chaotic energy. The water you drink today, it may have evaporated from a leaf a month ago, or fallen as snow 500 years back. So next time it rains, remember, that's not just weather, it's thermodynamics, fluid dynamics, and probability, raining from the sky. Math isn't magic, it's everywhere.